This is our RStudio mini project by Ethan Sainsbury, Jacob Britton Doucette, and Jacob Lawrence. Our agenda is beginning with the process of data cleaning, followed by the cross-fold validation, and then we have our building linear models section, and then lastly our predictions.
So this is Ethan Sainsbury. I'm going to start us off with some data cleaning. First off, we downloaded the documents off of Blackboard. We chose 2008, 2009, and 2010 to do a trifold data validation to try and predict the 2011 data for car crashes. Starting off, whenever we first downloaded the documents, they weren't in prime condition, so we needed to take it into our own hands to help clean it up a little bit, get rid of some of the blank values and the null values that didn't apply to our model. And so we also had to create an injury indicator, and we did this by creating an if statement, and we looked at the injury severity variable, and if it was equal to no, we would assign the value of 0, and if it wasn't, then it would be equal to 1, which means that there was a fatal car crash, and so, or there was a death within the car crash. And then what we did is we copied this entire column and then special pasted it to only paste the values in it so that it would not have the function behind it. And then this is what one of the Excel files looked like after we were done cleaning the data. And we only picked the variables that we wanted, which was state, age, sex, and route, and we kept injury indicator, of course.
And from there, we went into cross-fold validation. And since we had 3 sources of data, it's a 3-fold cross-validation. So here's a look at the overall cross-validation, which looks at all of our variables, sex, state, route, and age. As you can see in lines 12 through 15, this is just an example of us cross-validating the 2009 data set. So we just binded together the 2010 and 2008 and use that data to predict the 2009 data. And then from there, instead of doing it with all the variables, we went with just one at a time. So we went with sex, state, route, and age. And from there, we built some linear models. I'm just going to take you through a quick overview of what these actually are. There is a difference between a linear model and a generalized linear model. Just a regular old linear model follows a normal distribution, and it uses the LM function in R. And the generalized linear model follows the GLM function in R, and it's based off not just a normal distribution. It could be exponential, Poisson. In our case, we use binomial. And so here are our results in R from just the regular old linear model. As you can see, it shows the correlation coefficients under the estimate column. It also shows the standard error and the t-value as well as the p-value. And then here's our results for the generalized linear model, which looks almost the same as the linear model. And I just want to point out that it does show the deviance residuals, meaning that it'll show all the quartiles as well as the minimum value and the maximum value.
And here we have our predictions portion of the PowerPoint. And we started with the overall data. So we used sex, state, route, and age from 2008, 2009, and 2010 in a trifold cross-validation to predict eventually that there would be roughly 33,600 deaths in 2011. And then we also did that for each individual variable. So for sex, we predicted that there would be roughly 32,900 deaths. And for state, we predicted that there would be roughly 32,800 deaths. For route, we predicted that there would be roughly 33,800 deaths. And then age, we predicted that there would be roughly 32,000 deaths. And as you can see, all of our values were between 32,000 and 34,000, meaning that our data is precise and is all, if all goes well, accurate as well. Thank you.